Algebra 2, Chapter 6, Section 2, Part 2, Polynomials and Linear Factors. Okay, what we're going to work on in this section is factors and zero properties of polynomial functions. We've already talked about the roots and the zeros of polynomials. All right. The highest degree of the polynomial is going to tell us how many possible zeros or possible roots there are. So let's step into it. Finding the zeros of a polynomial function. Find the zeros of this equation. Okay, this is a factored form polynomial. So if you need to, let's rewrite it and let's just work through the process. And there's obviously, once you see it, there's a much quicker and easier way to do it. So we have three sets. So we know this is a cubic. We know we have three zeros. Set each grouping equal to 0 and solve. So x minus 2 equals 0, so x equals 2. The middle one, x plus 1 equals 0, so x equals negative 1. X plus 3 equals 0, so x equals negative 3. So our zeros are 2, negative 1, negative 3. And again, really quick, let's just talk about how we graph this. And again, you can tell I'm not too concerned about it being perfect. I just want to understand concepts right now. So these are roots are zeros. So when x equals 2, we have a 0. When x equals negative 1, we have a 0. And when x equals negative 3, we have a 0. So we'll just label that negative 1, negative 3, and 2. All right, we've got to find the curve. If you remember, we talked about it would have a curve like this or a curve like this. So we've got to pick a point between two of the zeros and find out if it's going to be positive or negative. Since 0 falls in between, right, these two, I'm going to use 0. So let's plug 0 back into the original equation and let's just solve. All right, so y equals 0 minus 2 times 0 plus 1 times 0 plus 3, which would be negative 2 times 1 times 3. So when x equals 0, let's make sure we understand this. We'll solve for y. So y is going to equal negative 6. So when x is 0, y is negative 6. Okay, so there we go. So we know we have a graph that looks like this. And again, we don't know if that's the maximum or the minimum. We don't know if that's the minimum or not, but we do know it's going to have a curve that looks like this. Okay? And again, with a graphic calculator, we could do that a little bit more exact, and we could plug and chug and find the relative maximum and the relative minimum. But the main thing is I want to understand the point to find the zeros. All right, so for A, find the zeros of the function. Well, what's x have to equal here to make that 0? 7. What's x have to equal here? 5. What does x have to equal here? 3. So you don't have to do every step. You can just look at it by inspection and find the zeros of 7, 5, and 3. So it says graph it. So we got to find the ones that have 3, 5, and 7 as their zeros. And we find 3 of them. This one's negative, so that one's out. Okay, now how do we find which one of these works? Well, let's just pick a line. I'm going to pick this one since that looks like a minimum. So when our x value is 6, we can solve for y, and then we can pick the correct graph. So when x equals 6, we can solve this thing. Y equals 6 minus 7 times 6 minus 5 times 6 minus 3. So that's going to be negative 1 times 3. So that's going to be negative 3. So when x equals 6 on that line I just drew, y equals negative 3. 1, 2, 3. So that one meets the criteria. That one does not. That one does not. So our answer is A. Again, understand the curves. Okay. Now, here's the factor theorem. The expression x minus a is a linear factor of the polynomial if and only if the value of a is a zero of the polynomial. Okay? So let's go back real quick. So 7 is a 0, so x minus 7. 5 is a 0, so x minus 5. And 3 is a 0, x minus 3. So it works. Okay? So now, write a polynomial function in standard form with the zeros at -2, 3, and 3. So I know I have zeros at -2, 3, and 3. So I can write this polynomial as x minus -2 times x minus 3 times x minus 3. So I can rewrite this as x minus -2 is the same thing as x plus 2 times x minus 3 times x minus 3. It says put it in standard form. So if you remember how we did that, I'm going to draw a line right here. And we're just going to go ahead and distribute. So x times x is x squared. X times -3 is -3x. -3 times x is -3x. -3 times -3 is +9. We can simplify this to x squared minus 6x plus 9. Don't forget to drop down our x plus 6 or x plus 2. Okay, now we got to factor this out. So x times x is x cubed. X times -6x is -6x squared. And x times 9 is 9x. Okay, there's no more terms on the right side, so go to the left. 2 times x squared is 2x squared. 2 times -6x is -12x. And 2 times 9 is 18. Now we can sum like terms. So we get x cubed minus 4x squared. Should have been 9x, by the way. Minus 3x plus 18. So that is our standard equation, or standard form polynomial for zeros at -2, 3, and 3. So I have x cubed minus 4x squared minus 3x plus 18. Alright, so write a polynomial function in standard form with zeros at -4, -2, and 1. So I can say, I know the p of x, or y, doesn't matter, equals x minus -4. Okay, again, remember how I did that before, minus with a negative sign. X minus -2 and x minus 1. Okay, let's go ahead and multiply these out. X times x is x squared. X times -1 is -1x. 2 times x is +2x. 2 times -1 is -2. Okay, so I can rewrite this as x squared plus x minus 2. Now I'm going to multiply and distribute x plus 4. So x times x squared is x cubed. X times x is x squared. And x times -2 is -2x. 4 times x squared is 4x squared. 4 times x is 4x. And 4 times -2 is -8. Sum like terms, so I'm going to get x cubed. Looks like plus 5x squared. You see I'm underlining like terms. Plus 2x minus 8. So the answer would be, in our notes, B. Alright, on to the next example. Writing a polynomial function in example 5 has 3 zeros. It only has 2 distinct zeros at -2 and 3. If a linear factor of a polynomial is repeated, then the zero is repeated. A repeated zero is called a multiple zero. A multiple zero has a multiplicity equal to the number of times the zeros occur. So in example 5, the 0, 3 has a multiplicity of 2. So finding the multiplicity of a 0. Find any multiple zeros of this function. X to the 4th plus 6x cubed plus 8x squared. Well, the first thing I notice is I can factor out an x squared. What's left? X squared plus 6x plus 8. Okay, so let's x factor that. A times c is 8. My b value is 6. So what two numbers give me a product of 8 and the sum is 6? I see 4 and 2. So I can rewrite this as x squared times x plus 4 times x plus 2. Alright, what are my zeros here? Well, I have 0 and a 0 because it's x squared. Alright, the 0 right here would be negative 4, and the 0 right here would be negative 2. Alright, since we can rewrite as it's saying here, the x squared is x minus 0 twice, you know you have 0 with the multiplicity of 2. So 0 with the multiplicity of 2. Okay, let's do another example. For this, for f of x, x minus 2 times x plus 1 times x plus 1 squared. Find the multiple zeros. Well, the 0 for this one is 2. The 0 for that one is negative 1. The 0 for that one's negative 1 twice. So I have negative 1 3 times. So I have a multiplicity of negative 1 of 3. Does that make sense? Pretty simple concept once you understand what we're doing. Okay, next example. Find multiple zeros and state the multiplicity. So let's write it x cubed minus 4x squared plus 4x. I can factor out an x, so I'm going to get x squared minus 4x plus 4. Well, my a times c value is 4, my b value is negative 4. What two numbers give me a product of 4 and a sum of negative 4? Negative 2 and negative 2. So I could rewrite this as x times x minus 2, and if I wanted to, go ahead and go x minus 2 again so you see it. What are my zeros? Well, that would be 0, 2, and 2. So I have 2 multiplicity of 2. So 2 of 2. The answer is C. Okay? Getting there. So, equivalent statements about polynomials. Example is this. Negative 4 is a solution of this. So negative 4 is an x-intercept of this. Negative 4 is a 0 of this. And we know x plus 4 is a factor. So once we know a root, once we know a 0, all those are true. Once we know negative 4 is a solution, negative 4 is an x-intercept, it is a 0, it is a solution, and x minus that is a factor. It's good stuff to know. All right, that concludes 6.2.